So today, as we're covering the rest of 4.7, today the first thing we're going to work with is we're going to use our point-slope form to help us write an equation in slope-intercept form. We've already done writing an equation in slope-intercept form, given a point and the slope. We've already done that. We've already done writing an equation in slope-intercept form, given a point that's not the y-intercept, and given the slope. We found b, and then with our given slope, we were able to write the equation. We've also done, if we're given 2 points, write the equation in slope-intercept form. We had to find the slope first, then we had to go find b, and then we were able to write our equation in slope-intercept form. Today they want you to be able to do it from point-slope form. Okay, so in our first one, we're given the slope, so we don't have to find it, and we're given a point that's on the line. Is that point the y-intercept that they gave us? Negative 3, 8. No. How do we know that's not the y-intercept?
X is not equal to 0.
X is not equal to 0. If x was equal to 0, we could go right to putting this into slope-intercept form. But because x is not equal to 0, this point is not the y-intercept. So what we're going to do is we're going to write this equation in point-slope form first. So remember, our point-slope form goes, can you recite it for me? How's it go?
Y minus y sub 1 is equal to x parentheses, no, m parentheses x minus x sub 1.
Okay. If you don't have that memorized, probably want to get that written down so that, because that's the first thing we're going to do is we're going to put it in our information we have into that form, and then we're going to rearrange that so that it's in slope-intercept form. Okay? So we're going to put, what would our equation be? Y minus what? 8 equals negative 1/3 times x minus negative 3, right? Or in other words, this is our m value right here. This is our x sub 1. This is our y sub 1. Let's clean that up. Negative 1/3 times x plus 3. What's the first thing you think we probably better do? Remember, we're going to get the y alone. That's what the goal is when we have it in slope-intercept form. So what would you think the first thing we would do is?
Add 8.
No. I don't think I'd add 8. Yes,
distributive property.
yeah, we always want to simplify first before we start doing anything to both sides of the equation, before we start, as we call it, solving it. So let's simplify this first. Let's do our distributive property. So we're going to get y minus 8 equals negative 1/3 x plus, what's 1/3 of 3? 1. And what's a negative times a positive? Negative. So it's going to be plus a negative 1. So negative 1/3 times 3 is negative 1. Now we've simplified it. Now we're actually ready to get y alone. Okay, so what would be our next move? Now we would add 8 to both sides. Get rid of that, subtract 8. And do you see why it's more beneficial now to add the 8 now? Because otherwise we would have had it outside those parentheses and we still would have had to do that simplifying first. So we have y by itself, negative 1/3 x plus what? 7. So we have it in slope-intercept form. So we now know something about the behavior of this line. Tell me something about the behavior of this line. What was it? It doesn't go through the origin. It's not a direct variation then, right? Okay, tell me something else. Will it rise from left to right? Fall from left to right? Fall from left to right. How do we know that? The slope is negative. Where will it cross the y-axis? And positive 7. Okay, so we know some things about this line without graphing it. So any questions on what happened there? What we did and why we did it? Okay, look at number 2. We have to write an equation for the line in slope-intercept form that has those 2 points. So what's our first move going to have to be? We're going to find the slope first of all. Okay. So our first move is we got to use our slope formula and find the slope. Anybody want to do our setup upstairs for us? What would the setup upstairs be?
5 plus 5.
So you're going to do 5, you're going to use this point first and then take away the other one. Okay?
Negative 1 plus 3.
And negative 1 subtract a negative 3, and yes, we will change those to add the opposite. We want to make sure we have a good setup to start with here. So starting with, in other words, basically call this our y sub 2, and this is our y sub 1, this is our x sub 2, this is our x sub 1. Okay, so change it to add the opposite, add the opposite. What's our rise? 5 plus 5?
10.
10. What's the run?
2.
2, negative 1 plus 3. Simplify. 5. Okay, so we now know that the slope is 5, and they want us to write, they want us to use the method today where you put the equation first in point slope form, and then you go from there and put it in slope intercept form. Now, are either the points they gave us the y-intercept? No, so we can't shortcut it anyway. So we're going to use the point slope form like they're asking us to. So which point do you want to use? Does it matter? Should it matter which point we use? No. So which one do you want to use?
Negative 1, 5.
First one?
Yes.
All in favor of the first one? Thumbs up. Okay, let's go. We're going to do, we know that m is 5, okay? And we're going to use the first point was decided. Okay, so we're going to do y minus 5 equals, that's the 5, the y value from the point. And now we have a 5 for our m, and x minus what? Negative 1. Okay, we can clean that up and make it plus a positive 1, right? What's our next move?
Distributive property.
Distributive property. Let's simplify this before we try and get y alone. So we're going to take our 5 times the x and the 1, and we should have 5x plus 5 now on that side. And what's next?
Add 5.
Add 5. Okay, Beeler, I'm going to call on you personally. I'm going to call you out on who's going to tell me the behavior of this line. Okay, you ready? Okay, Chaser, I want to know what this line's going to do. Is it going to rise from left to right or fall from left to right?
Rise.
It's going to rise from left to right. Elena, I want to know where it's going to cross the y-axis. 10. At 10. Braden, I want to know if it's a direct variation. It is a direct variation. Anybody want to challenge that, or do you all going to agree with Braden that this is a direct variation? Jared, what challenge do you want to put?
Oh, it's not a direct variation.
Okay, why is it not a direct variation? How do we know that?
It's adding 10 instead of 0.
It's adding 10 instead of, so because of this plus 10 right here, the plus b, in other words, if the y-intercept isn't 0, then it's not a direct variation. So maybe the first question should have been, what's the y-intercept? Or did I ask that? Did I ask where it was crossing the y-axis, right? It's crossing at 10, okay. So if it's not crossing at 0, then it's not a direct variation. That's kind of like a, it has to go through the origin, doesn't it? Okay. So how many of you think this is actually easier? Try and remember back, this was just last week. Try and remember back when you did have to use the slope and the point, and you had to find b, and then you wrote your equation in slope-intercept form. How many of you think this is maybe a little bit easier, maybe a little bit more efficient for you to be able to put an equation in slope-intercept form? Okay, a handful of you think it is already, and some of you maybe need to do it more. Okay, so do you remember how we did it when we had to find b? Anybody remember that process anymore? Or in other words, I'll just do it over here off to the side. Once we found our slope, then we would have put it into y equals mx plus b, and we would have, again, we would have used one of our points, so we would have put 5 in for y, we would have put 5 in for m, negative 1 in for x, and we would have solved it for b. Remember this? And then In fact, I just had some people who had to finish up that worksheet for me. It was just actually Friday's worksheet that you had to do some of this on. And what would we do next here? Add 5 to both sides to get the b alone. And looky there, b is 10. And what would our equation be? Well, y equals, our slope is 5, our b is 10. So we get the same equation because that line that has those 2 points and it only has one, it really is only one, it is the same line. It only has one slope-intercept form name. How many point-slope form names does it have though? How come it has an infinite number of point-slope form names?
There's an infinite number of points in the line.
Because there's an infinite number of points that you could use. There's one slope, but an infinite number of points. So we could give it several of these types of names. In fact, we could have given it a different name using the other point, couldn't we have? What should it have done though? What should have happened even if we would have used this point instead? What should have happened? Should we still have ended up with this in the end? We better have, yes. It only has one slope-intercept form name because it only has one slope and it only has one y-intercept. But point-slope form, it can have several names because it has several points, but it still only has one slope. Okay, what are we going to do in number 3? If they give us the x-intercept and the y-intercept, any ideas what we could do here? Abby?
Find the slope.
Find the slope. Okay, how are we going to find the slope?
Use the slope equation.
Use the slope formula. Okay, do we have some points?
Yeah.
Oh, okay, what are they?
-2, 0, and 0, 3.
Yeah. These intercepts are actually ordered pairs on the graph. There they are. And so now we're going to do just like we did in number 2. Our first move is we've got to find the slope. So we're going to substitute into our slope formula. Abby, go ahead and tell me how you want to do it.
3 minus 0 over 0 plus 2.
Okay. So yes, I started it out as 0 minus a -2, which then does become, if we change it to add the opposite, it does become +2. So 3 take away 0? 3. 0 plus 2? 2. So the slope is 3 halves. Okay. So we have our slope now. How hard do you really want to work here? Do you want to put it in point slope form? To get slope intercept form? I hope not. I hope you were looking for the shortcut. Anybody think they know the equation in slope intercept form now? So we have to go through all the work of writing an equation in point slope form first, and then getting it rearranged so that y is alone. Is that really what we have to do? Because you don't think you know otherwise? Dad?
Y equals 3 over 2x plus 3.
Yeah. We know the y-intercept, don't we? It's right here. We don't need to go through all that work. We know the y-intercept this time. So we can say the equation of this line is 3 halves x plus 3. Here we go. Good job. Todd just saved you all a bunch of work. You can say thank you. Okay. Anybody have questions about putting an equation in slope-intercept form when you don't know the y-intercept? And they want you to use point-slope form to get yourself there. Okay, then I think you need your books open to do the problem that we're going to do on the back. So if you want to get your books open to page 280. And we're going to do an application problem, which I'm going to guess should have shown up also in your SP3R as an application problem. That should have been one of the objectives. Okay, volunteer to read for us out loud, and the rest of us will follow along. Read problem number 35. Courtney, thank you.
At higher altitudes, water boils at lower temperatures. This relationship between altitude and boiling point is linear. At an altitude of 1,000 feet, water boils at 210 degrees Fahrenheit. At an altitude of 3,000 feet, water boils at 206 degrees Fahrenheit. Write an equation in slope-intercept form that represents the linear equation. Then find the boiling point at 6,000 feet.
Okay, thank you. So, you know, whenever there's a problem like this, they say there's a linear relationship. The first thing we're going to have to do is we're going to have to decide what should be the independent variable and what should be the dependent variable. And do you remember how we make that decision? So what are the two things that the variables would represent in this situation? Altitude in feet and temperature in, what's it measured in? Fahrenheit. Okay, so remember, what do? We decide which one should be upstairs, which one, yeah, so we got to decide what's going to be upstairs in slope. Dependent's upstairs, so we got to say, okay, does it make more sense to say feet per degree Fahrenheit or degree Fahrenheit per foot? What do you think? Which one makes more sense, do you think, to you for this situation? Should we say degrees per foot or number of feet per degree?
Degrees per foot.
Yeah, probably is. I think in this one we might want to do degrees Fahrenheit per, I don't want that to look so big, that should be littler. Degrees Fahrenheit per foot. So that means our independent variable is the what? It's downstairs, remember, the x's are downstairs. Independent variable is x, dependent variable is y. So independent variable is the altitude in feet, and the dependent variable is the temperature in degrees Fahrenheit. And that's important that we make that decision because we got to set up some ordered pairs here. Okay? Because they gave us some information that will help us be able to get the equation for this. Anybody think they know one of the ordered pairs, one of the relationships we can set up? Okay, Jacob.
1,210.
Okay, so at 1,000 feet, apparently the temperature is 210 degrees Fahrenheit. Is that right?
Yeah.
That's where water boils at? Okay. What's the other situation then?
3,000 feet, 206.
So we know that at 3,000 feet, it boils at what?
206.
206 degrees, okay. There's two ordered pairs for us. So what would be the first move we're going to make here? Find the slope. Okay, so let's find our slope. M equals. How about we do 210, take away 206. Doesn't matter. You get to pick which point you want to be first, but we have to make sure we just do it in the correct order once we do decide. Now, what is 210 take away 206? 4. Okay. And what is 1,000 take away 3,000? Negative 2,000. Now remember, we don't like slope to be a decimal, right? But this isn't going to be a integer, is it? So what we're going to do is we're going to say, okay, well, we'll simplify that as a fraction. What's a positive divided by a negative? Negative. Does 4 go into 2,000?
Yes.
Yeah, how many times?
500.
500. So we can simplify this by saying 4 goes into itself once, and it goes into 2,500 times. So we have negative 1/500th as our slope. And it's oftentimes weird when we are actually using it in an application problem. Okay? Now what are we gonna do? Remember our goal today is to be able to write an equation in slope-intercept form using point-slope form if we don't already know the y-intercept. Do we know the y-intercept? Do we know what it is at 0 feet, ground level, like sea level? No? Okay, so then we're gonna have to use point-slope form. Which point do you want to use? So we have m equals -1/500, and which of those two ordered pairs do you want to work with? The first one?
Yes.
Okay. 1,210. So we'll write our equation. Y take away 210 equals -1/500 times x minus our 1,000. Okay, now we'll do our distributive property. So we have y minus 210 equals a -1/500 x. And we change this to add the opposite up here. We see we're going to be taking a negative times a negative, which becomes a what? Positive. And 1/500 of 1,000.
2.
It's just 2, isn't it? Basically, all we're really doing, you guys, is this. You're saying 1/500 times 1,000 over 1. 500 goes into itself once, it goes into 1,000 twice. We get 2. Okay, we done? No, they want it in slope-intercept form, so our last move is add the 210. Okay, so add 210 to both sides. And we have y equals -1/500 x plus 212. Do we now know the boiling temperature in degrees Fahrenheit at sea level? What is it? 212, yeah, we know it now. Okay, so now we have one more thing to do. It says, then find the amount of water that will be left in the ship's tanks 50 days after leaving, oh, I'm the wrong one. Let's try this again. Then find the boiling point at 6,000 feet. Okay, they didn't say at sea level, so they said at 6,000 feet. So here's our equation. We did the slope-intercept form that they asked. And now we need to find temp at 6,000 feet. What are we going to do? What does it go in for, x or y?
X.
In for x. Because the x is representing the number of...
2.
Okay. So is x altitude?
Yes.
Okay, so we got to make sure we put it in the right place, because it doesn't always go in for x what they give you. Sometimes you might have to go in for y, so you got to make sure you make a good decision about where it's going to go in. So we do want it to go in for x, because x is representing, in this situation, altitude in feet. And we're not going to use a calculator. We're going to go like this. And see if we can make this happen. Okay, what can you do when you get zeros involved in your dividing? Can we just knock some out of there? Okay, so we got a couple of zeros on both of them. We can just say, bye guys. Okay. Does 5 go into 60?
Yes.
How many times? 12 times. And a negative times a positive is a negative, so -12. Look at that, we didn't even need to use a calculator. And I'm feeling pretty confident we're not going to need to here either. What's a -12 plus 212? 200. Okay. So what's our sentence answer going to be? Todd?
Water at 6,000 feet is 100 degrees Fahrenheit.
Okay, the boiling point at 6,000 feet. And is this above sea level or below? Above sea level, because it's a positive 6,000. Is 200 degrees Fahrenheit. Now let's abbreviate Fahrenheit and degrees. Okay, questions about that? Anything there along the way that didn't make sense?